The following video is on finding an angle between two lines. So the idea is that if I have a line here, L1, and then I have another line of L2, I want to find the angle between these two lines. Which angle am I talking about? The acute angle or the obtuse angle? Well, the mathematical community decided that the angle that we are talking about is the acute angle. So if you ever find the obtuse angle, then you're going to take 180 degrees, we'll subtract the obtuse angle, and that will give us the acute angle. Other things that you need to know. You need to know that if I have vector u and v, we can find what's called the dot product, u dot v, by, well, let's define what u is. U is u subset 1, u subset 2, and u subset 3. And v, vector v, is v subset 1, v subset 2, and v subset 3. Then the dot product is the product of our x values plus the product of our y values plus the product of our z values. Now, we are talking about finding the angle between two lines, but we can treat those lines like they are vectors. So when we treat them like vectors, we can use this equation of cosine theta equals u dot v over the magnitude of u times the magnitude of v. This equation, we can derive this equation from the law of cosines. Now you can YouTube that if you want to, watch lots of proofs if you'd like to, but we are not going to worry about that proof right now. It's also pretty relevant that we know that u dot v, if u dot v is greater than 0, well, what does that mean? Well, if u dot v is greater than 0, that means that we have a positive value here because the denominator is always going to be positive. So what does it mean if cosine theta is positive? Well, what is cosine theta? If we consider the unit circle, cosine theta for the unit circle is the x value. So when is the x value positive? Well, in the first and the fourth quadrant. So from our initial side, when we rotate and our terminal side is in the first quadrant, we have an acute angle. Or if we rotate and our terminal side is in the fourth quadrant, we also have an acute angle. So it means, what it means to have u dot v, or the dot product of our two vectors, to be greater than 0, what that means is that we have acute angle. We have an angle. We have an acute angle. Now, when is cosine theta negative? When is cosine theta less than 0 or negative? Well, cosine theta, again, is our x value, and if we consider our unit circle with a radius of 1, where is x going to be negative? Well, from our initial side, actually, the x value is always going to be negative to the left of the origin, so that means our terminal side is either going to be in the second quadrant or in the third quadrant. So this rotation here from our initial side, or a rotation the other way around, or many different ways, many different rotations, as long as our terminal side is in the second or the third quadrant. So if u dot v, if it's negative, then I have a negative over a positive. I have cosine theta, which is negative. That means we terminate in the second or third quadrant, so we have an obtuse angle. Well, what does it mean to have u dot v equal to 0? Well, let's look at our unit circle again, and let's label these points here. We have, for our unit circle, this point right here is 1, 0. This point right here is 0, 0, positive 1. This point here is negative 1, 0, and this point here is at 0, negative 1. Now, again, cosine theta, that is our x value for a unit circle. So what kind of rotation will get us to cosine theta equaling 0? Well, from our initial side, we're looking at this rotation. So cosine of some angle equals 0. Well, that's 90 degrees. So cosine of 90 degrees equals 0. If we rotate the other way, so cosine of negative 90 degrees equals 0. Or we could rotate all the way around here. That's going to give us 270. So cosine of 270 degrees, or negative 270 degrees, right, will give me 0. But the relevant thing that you should see is that when we terminate on this vertical line here, from our initial side, we are looking at perpendicular angles. So what does it mean to have u dot v equals 0? It means we have a perpendicular angle. So angles are perpendicular. All right, what else should you know? You should also know the different kinds of equations. We have vector equations, parametric equations, and Cartesian equations. Here I've given you a parametric equation, so I've given you parametric equations. And we can use these parametric equations to write a vector equation. So our vector equation would be xy equals -1, 11 plus t times our direction vector of -2, 1. If we wanted to find our Cartesian equation, we would solve for t. That value, whatever t equaled, we would plug it into the other equation, and then you would have one equation in terms of x and y only, and then you could, however you wanted to manipulate it, you could rewrite it as slope-intercept or point-slope form or standard form, whatever acceptable Cartesian equation you can think of to write it in is open game. So let's jump into a couple of problems here. It says, so I want to find the angle between L1 and L2, and both of these equations, it looks like, are written in as parametric equations. So let's translate these parametric equations into vector equations. So we have -4, 3 plus t times the direction vector of 12, 5. And our other line, L2, we have 0, -6 plus s times our direction vector of 3, -4. Now, if you consider that we have some starting point here, and we have some direction vector, and some starting points over here with a direction vector here, you can see that the only thing that really matters to find this angle between these two vectors is the direction vector. So the only thing that matters is these vectors here. So I'm going to use our equation of cosine theta equals u dot v over the magnitude of u times the magnitude of v. Now I'm going to solve for theta, so I'm going to take the inverse of cosine to both sides. So I get that theta equals the inverse of cosine of the dot product of u and v, which would be 12 times 3 plus 5 times -4 over the magnitude of u, so that would be the square root of 12 squared plus 5 squared times the square root of the magnitude of our second vector, so that would be the square root of 3 squared plus -4 squared. I'm going to throw that all into my calculator. So that's going to give us, so I'm just going to clear all this. So that's going to give me the inverse of cosine of, I'm going to use a bunch of parentheses, so I'm going to get 12 times 3 plus 5 times -4, and then all over the square root of 12 squared plus 5 squared times the square root, let's make sure we're outside of the square root, times the square root of 3 squared plus -4 squared. And I get 75.8. 75.8. So theta equals 75.8 degrees. Now because 75.8 degrees, that is an acute angle, it's less than 90, then we're done. That was the point when we're trying to find an angle between two lines, it has to be acute. Now if we look at number 2, we have two other lines. Both of these are also written in parametric equations, so let's rewrite them as vector equations. So L1 is 2, 19 plus p times our direction vector of 5, -2. And L2 is going to be 3, 7 plus r times 4, 10. I want to reiterate that the important vectors that are relevant for finding an angle between two lines are only the direction vectors. Now it says here, I want to show that the lines are perpendicular. Well, if I want to show that they're perpendicular, I'm just going to show that u dot v equals 0. So that'll give me 5 times 4 plus negative 2 times 10. Does that equal 0? Well, 5 times 4 is 20. And then negative 2 times 10, that gives me negative 20. And, well, that gives me 0 equals 0. So I just showed that the angle between these two direction vectors is 90 degrees. Let's look at number 3. Now, I have two different lines here. We have L1, which is at, it looks like it's parallel to 4, negative 3, so that's going to be my direction vector. So I have negative 6, 3, plus, I don't know, t times 4, negative 3. And then L2 is at 0, 8, plus, I don't know, s times our direction vector of 5, 4. And the only thing that matters when it comes to angles is our direction vectors. So I want to show, it says, I want to find the acute angle between these two lines. So I'm going to use cosine theta equals u dot v over the magnitude of u times the magnitude of v. Find the inverse of cosine, so theta equals the inverse of cosine of the dot product between u and v, so that would be 4 times 5 plus negative 3 times 4 over the magnitude of each of the vectors, so that would give me the square root of 4 squared plus negative 3 squared times the square root of 5 squared plus 4 squared. I'm going to throw all these into my calculator again. I'm going to go highlight and rewrite as 4 times 5 plus negative 3 times 4 all over the square root of 4 squared plus negative 3 squared times the square root of 5 squared plus 4 squared. That gives me something very close to what we had before. We have the square root, we have 75.5 degrees. 75.5 degrees. 75.5 degrees. This is also acute. It is less than 90 degrees, so we're good. Let's look at number 4. Number 4 says, find the angle between the two lines. Well, again, we're just going to use our direction vectors, do the same thing that we did for 1 and 3. That should be fairly easy, so I'm going to skip 4a. If we look at 4b, it says a third line, L3, is perpendicular to L2 and has a direction vector of, well, 0, negative 3, and x. So if I know that these two lines are perpendicular, I'm going to use u dot v equals 0 to find out what x is. So the dot product of these two vectors would be 3 times 0 plus negative 16 times negative 3 plus 7x equals 0. Well, 3 times 0 is just 0. And negative 16 times negative 3, that's negative times a negative, which is a positive. So I have 16 times 3, which is 18, 3, 4, 48. I have 48 plus 7x equals 0. I'm going to subtract 48 from both sides. So that would give me 7x equals negative 48. Divide by 7, that gives me x equals negative 48 over 7. That is what x equals. So I'm going to do one more problem and then we'll be done with this particular video. It says, so for number 5, there are 4 different problems. I'm just going to do one. It says, find the measure of the angle between the lines. So both of these equations are written in Cartesian equations. So I'm going to rewrite both of these in slope-intercept form, y equals mx plus b. Because this slope here, this becomes pretty relevant and is equivalent, not exactly the same, but very similar to what a vector is. So I'm going to subtract x from both sides. That gives me y equals negative x plus 7. We'll do the same thing over here. I'll subtract x and and we'll subtract 2 from both sides. It gives me negative 3y equals negative x minus 2. Divide by negative 3 to both sides. It gives me y equals 1/3 x plus 2/3. Now, a slope, or my m value, is my rise over run, or the difference between my y values over the difference between my x values. So we're really looking for the slope, our up value over our left-right value. So whereas for our vector is written as our x value over our y value. So the vector for our first equation is going to be, well, our slope right now is what? Negative 1 over 1, or 1 over negative 1, it doesn't matter. So our vector then is going to be negative 1 over 1. For our other vector, if our slope is 1 over 3, or 1/3, then our vector then is going to be 3 over 1. And if we're trying to find the angle between these two equations, then we're going to use our cosine theta equals u dot v over the magnitude of u times the magnitude of v. Take the inverse of cosine, so theta equals the inverse of cosine of u dot v. Well, u dot v is going to be negative 1 times 3 plus 1 times 1 all over the magnitude of our first vector, so that would be the square root of negative 1 squared plus 1 squared, times the square root of 3 squared plus 1 squared. I'm going to throw that all into my calculator. Oops, wrong button. Here we go. And that's going to give me negative 1 times 3 plus 1 times 1 all over negative 1 squared plus 1 squared times 3 squared plus 1 squared. That gives me 116.6. Well, the problem is 116.6, that is obtuse. So if we want to find the angle, the acute angle, we're going to take 180 minus that angle. That's going to give us our 63.3. Or we can make sure that our numerator is a positive number. So let's see, in our numerator we have negative 1 times 3, which is negative 3, plus 1 times 1, which is 1. So I have negative 3 plus 1, which is negative 2. So all this becomes negative 2. But negative 2 is negative, which means it's going to be obtuse. So I'm going to make it positive, so we'll just make this 2. And we get the same angle of 63.4. So we have theta equals 63.4 degrees. Hope this video was helpful, and have a wonderful day.